get a value of 36 Newton, and resolving along the vertical direction we have 151.6 Newton. So substituting in the resultant force, formula for resultant force, we have 155.8 Newton. Guys, I'm not getting the things in detail because you need to understand the concepts. If you don't understand what I'm explaining, that literally means you haven't understood the theoretical section. Please go through the theoretical section. In case you find much difficulties, I'll get you some links on the description box. You could go through them also, and you will find, and after that you can clear your concepts. Also, if we need to find the resultant, the angle in fact that makes that the resultant makes with the horizontal force, we need to find it by substituting the values of the summation values of the vertical and the horizontal forces in this formula. Tan theta equals to summation of vertical forces by summation of horizontal forces. So it comes down to 4.211. After that equating, we have theta equals to tan inverse 4.211. It gives 76 degrees approx. So moving to the next segment, that is the next problem. Kindly look at the diagram that I have drawn. So there are three forces: 30 newtons, 25 newtons and 35 newtons. These are inclined at an angle of 45, 30 and 40 respectively. So again, if we equate resolve the forces, horizontal forces, we get minus 30.7 Newton and the vertical forces as 33.7 Newton. So similarly we can find out the resultant force in fact, and substituting in the tan theta value, we have theta equals to 47 degree approx. Now there's a question here: will the actual angle that the resultant makes with the horizontal be 47 degrees? No. Here we have the horizontal summation of horizontal forces as negative force and the vertical force as positive. So theta lies between 90 and 180 degrees. That is in the second quadrant. So the actual angle will be 180 minus 47.47 equals to 132 degrees approx. So similarly, if we see the next problem, we get horizontal summation of horizontal forces as 5 kgf, and the resolved summation of vertical forces as minus 85 kilogram force. So we can easily find out the resultant, and it comes to 85.15 kilogram force, and the angle which the resultant makes with the horizontal is around 87 kilogram force. So guys, these are the answers literally. I want you to go through do the sums, do the problems and find out the answers. In case you have any problem, just leave a comment in the comment section. So getting back to the problem, here again there's a problem like is the actual angle that the resultant makes is 87 degrees approx. No, it isn't, because here again the horizontal force is 5 kilogram force and the vertical force is minus 85 kilogram force. So the actual angle lies between 270 and 360 degrees, that is in the fourth quadrant. So the actual angle will be 360 minus 87. It comes to approximately 273 degrees. Moving to the next problem, this is a problem from mass and weight that we have explained in the last video that covers the mass and weight section. So there's a body here of 1.5 meters long, and this body is tied at an angle of 60 and 45 degrees to the points A and D. So what we need to find out is the tension on the string A. We need to find out the forces F2 and F1, that is the tensions F1 and F2 at the points A and D respectively. So we have mass as 100 kg that is given in the problem. Weight we can easily calculate as 100 into 9.8, it comes to 980 newtons. Now similar to the other problems, we resolve the forces horizontally and equate it to 0 because the body is in equilibrium. So we get an equation like F1 equals to 1.414 F2, and also the resolved vertical forces, the value of the resolved vertical forces in fact is given as 980. So again equating them to 980, we get the two forces F2 and F1 as 507 and 718 newtons respectively. Thank you guys. I'll meet you in the next video.